So good morning, everyone. We will be starting in about a minute. I'm going to let a few more attendees in, and then we will start with our agenda. So good morning to all of you speakers and attendees. Good afternoon to those of you who are joining us from mainland Europe and Scandinavia. And welcome to this webinar on zero-emission aquaculture service vessels. My name is Anna Margrét Corneliusdóttir, and I'm a project manager at Icelandic New Energy, a Reykjavik-based company with the sole purpose of eliminating fossil fuels from transport. We support and promote clean energy options for all modes of transport and mobility, be they land-based or sea-based. I am happy to guide you through today's agenda on behalf of 4 entities based in the Nordics, namely Icelandic New Energy, NORA, which is a short term for Nordic Atlantic Cooperation, an organization under the Regional Cooperation Program of the Nordic Council of Ministers. It brings together Greenland, Iceland, Faroe Islands, and coastal Norway. I'd also like to mention Nordmar Ports, a project funded under Iceland's 2019 chairmanship of the Nordic Council of Ministers, whose objective is to strengthen the role of port ecosystems as drivers of sustainability in ocean-based industries. Finally, we have, for this webinar, enjoyed the support of Blámi, an Icelandic project in the West Fjords working to inspire the development of innovative energy transition projects and attracting partnerships for research, demonstration, and development. So today we are here live from 3 different countries. I'm based in Iceland. Richard Mortensen from Mass Shipyard is based in Faroe Islands. And we have Thomas and Vekar based in Norway. And today we will be discussing different zero-emission solutions for aquaculture service vessels. Now, why are we discussing this and not the big cruise ships? Well, though this is an established industry, aquaculture has been a fast-growing one in the North Atlantic area in particular. Often, these activities are located in vulnerable cold ocean ecosystems, narrow fjords with biological communities sensitive to pollution, vibration, noise, and other disruption related to human activity. Many of the farms are located relatively close to shore, which provides an excellent opportunity to be serviced with battery-powered boats, fuel cells, or a combination of the both. So the companies, obviously, as in other industries, are increasingly taking environmental responsibility and keen to improve their carbon footprint and research the next step into zero-emission service boats. And that is the purpose of this webinar here today, is to discuss and raise awareness in the industry of solutions that are already commercial or are close to becoming commercial. And obviously, if we were live today, this would also serve as a networking event. But alas, we do our best considering the coronavirus pandemic status. At any rate, you can get in touch with the speakers afterwards and set up a meeting to discuss further, or you're also welcome to get in touch with me. But before we start, I'm going to go through some practical issues. We have time allowed for some questions between speakers, but I will be very strict and make sure that we don't run over the time limit. Please use your Q&A option on your Zoom interface for questions to the speakers, as all the attendees are muted and not on camera. So Q&A will be your line of communication. You can also use the chat for information on audio or video quality. I have also activated the upvote function for Q&A, so that way you can vote for a question you would like answered or is perhaps similar to the one you would like to pose. My co-host and I will try to select the most voted for questions and work our way from there. And if we do well and have time for extra questions at the end, we will try to do so. I think we can soon start the webinar. I actually just remembered that the last webinar we had, we actually had an earthquake during the webinar, so I'm quite excited to see what happens today. But I'd like to welcome our first speaker here today. This is Richard Mortensen. He is from Mest Shipyard in the Faroe Islands and acts as head of sales and procurement. And now I leave our fate to technology and see if we can see Richard's presentation.
So are we there, or?
I think you need to go to display settings above the slides on the left.
Just a second, I do them once more.
There we go. Thank you.
There we go, yeah. Thank you very much. Hopefully you can hear me here from the Faroe Islands and Tórshavn. I'm very happy to introduce the first Faroese zero-emission aquaculture workboat. We are actually working on this at the very moment down in our building hall here. And we actually won this project in competition with a number of other companies. So we are very proud that we got the opportunity to work on this one. But before I start, just a brief introduction on who we are, Mest Shipyard. See what happens here. Here we go. We are a shipyard with more than 120 years of shipbuilding and ship repair experience, with 500 skilled craftsmen, 2 shipyards, and 1 stainless steel workshop. We have a net sales of 420 million Danish kroner. We have a dry dock and a slip in another island in Skala, where you can see there are good facilities, and we are fairly active in this place. Facilities in Tórshavn with a number of construction halls, garages, machinery departments, 2 slips. Actually, in the working hall nearest to us on the bottom of the picture is where the work is happening at the very moment, building the new zero-emission workboat. On the very left of the picture, you can see a red building and a yellow one. That's where our headquarters is. This is where I am based at this very moment. So welcome to our place. We have construction halls and workshop, and we serve a number of companies like Wärtsilä, ABB, and other ones where we have skilled people who do that. We invest into modern equipment all the time so that we are ahead of the game. One part which we are particularly proud of is our drawing department, where we have some 13 employees, and we have state-of-the-art equipment, software and hardware, and we can undertake all the work all the way from the very beginning to the very end of of design, consultancy, and project management. This is our company in Runavik, which is mainly stainless steel, and we serve here mainly onshore companies like fish filleting factories, the salmon industries, and others. Our customer base, we have both sea and land-based customers, all the way from, as you can see on the top, catamaran workboats, the salmon industry you can see on the bottom left. We do rebuilding projects, all the way to serving windmills as well, where we do have service agreements with the German Enercon in the Faroe Islands. We are participating in a number of innovative environment solutions. Here you can see the windmills again, and on the very middle of the picture, you can see a vessel. It's actually a ferry where we have installed some wave foils, or you can call it wings, on the vessel. And that's in order to reduce motion so that it doesn't rock too much, and to save fuel, actually. So this installation has saved fuel by 10 to 15%. So that's fairly interesting. It's a Norwegian solution which we have installed. And on the very right hand to the bottom there, you can see a Minesto project, where we are part of a Swedish project which undertakes tests to generate electricity from the ocean, from the current and tidal energy. And this is a kite which sweeps below the water, so that's very advanced. We are based, as you can see, in the middle of the North Atlantic, 1 hour's flight from Iceland, Norway, and Scotland, and we find ourselves in the middle of the world. Our perspective is that we are in a maritime sweet spot. We find that it's a lot of maritime activity happening in our area. Because the size of the country Faroe Islands is so small, and we have connected all the islands with either subsea tunnels or bridges, we are very flexible when it comes to serving customers. So we have a high degree standard of infrastructure, skilled workforce, and collaboration between the companies is key. That's very good collaboration between the different companies in the islands. So our main aim is to give quick service and a short dwelling time or downtime for factories. So in most cases, you are maximum 1 hour away when you need some services. Over the last many years, we have built 114 new builds at Mest. We are very proud to have delivered this large new oceanic research vessel, which was delivered in 2020, where we undertook the work. It's probably, as we say, one of the most quiet vessels in the world. It's almost like James Bond. You cannot hear anything in the sea. So they can do some very accurate research regarding the fish. And we also undertook the state-of-the-art accommodation for the company. So it's a modern vessel which attracts good employees as well, both researchers and people who work on board. Here's an example of a recent example where we claim it's sustainability in action. We took into the very left this very old, 20 years old workboat, which is called Stenganes, and took complete overhaul and upgrade with new engines, new hydraulics, new crane, new accommodation, thorough surface treatment, etc. So actually, the company Bakkafrost now has a new vessel, in theory, or in actual fact, at a very low cost. So that could be one way forward to do some proper overhaul and maybe install some other things than just typical engines. You could install batteries or other solutions on board vessels like that. So this is sustainability in action. Now, coming to the green workboat, which we started on some months ago. The specifications is that it's a length of 15 meters times 7 meters width. And here's a number of specifications, but we could say that there's a recommended speed of 8 knots, the estimated max speed at 10 knots, and the bollard pull is 9 tons. So it lives up to all the criteria our customer has. If you say look at the solution in short, all the design is energy saving. The whole design, the choice of equipment, etc. The selected battery solution is available to use today. That was very much a key. Other energy solutions were investigated, but no one was ready for use in the very near future at that time. The working day becomes quieter, cleaner, and easier for the people on board. The solution can be implemented immediately when the boat is ready, and all the work is carried out in the Faroe Islands. We opted out biogas, hydrogen, and other options at that moment. Hydrogen, there was missing class approval. Lack of infrastructure in the Faroe Islands. Hydrogen has a higher kilowatt-hour price than battery, and the expected additional price in the operation would be around 300,000 Danish kroner per year compared to a battery solution. Biogas. You need a big tank on board, a very big tank, an engine to burn the gas, and there's a noise pollution on board as well at that given technology which we looked into. Methanol and ammonia, still on test basis and not ready at the moment, and the supply is not in place here in the Faroe Islands. And we have seen other solutions where we have visited various conferences, and we can see very proper solutions and fantastic interest, very interesting ones. And when we asked the question, would there be possible to implement this? They say, oh no, not yet, because typically the infrastructure is not in place. Not in places like Faroe Islands, at least. We undertook some very advanced computer simulation to identify the most optimal hull solution in order to gain less resistance and we gained 9 to 10% energy saving, which was very important for the solution. And the propulsion engine and all of that is all designed to have high power and less energy waste. And we had also propellers which had controllable pitch and energy optimization, which led to 130 kilowatt to 8 nautical miles per hour. But as I mentioned before, it can go up to 10. So everything designed in order to optimize and have energy saving. The battery solution was from Brunvoll in Norway. Why Brunvoll? Yes, because we know this manufacturer, a very reliable manufacturer, who provides solutions to Norwegian companies and actually to a Faroese ferry, which was delivered, I think it was last year, to Erla Kongsdottir, and it's working very well. It's a relatively light and compact solution and designed for long life, and thereby an environmentally friendly solution. Also, we could say that the electrical solution, it takes the environment seriously. The battery itself is from Corvus, and I think it's a Canadian manufacturer. It was based in Norway as well. And the supplier includes the environment and recycling in their solution. And this is a significant part of their strategy. The purpose is to maintain a sustainable life from birth to death. When the batteries are worn out on the catamaran, about 70% of the energy from the batteries can be recycled, e.g. at smolt stations with bakkafrost. This was very interesting for them. And here is the source from Brunvoll. Construction costs, it's built in the Faroe Islands, all of it. The price is the same for the hull, the equipment, etc., as on other catamarans. The costly factor is the battery solution. Battery prices are, though, expected to be reduced to a third over the next 5 years, according to our sources. Now, everything depends on various aspects like Corona, etc., but at that moment, that was the case. Operating cost, which was an important parameter for the company, it's a total of 311 kroner per hour. It's converted to 3.12 kroner kilowatt hour. And it's cheaper to operate than traditional workboats. So this was important for them. As I mentioned, all work is undertaken in the Faroe Islands. Here is the workboat itself. In the middle of the picture, you can see it gets some interim surface treatment, and then it will be final treatment, will be painted blue as well. And there has been some delay of deliveries due to Corona, and mainly the battery solution. So that will happen we will receive the batteries in January. We should have received them in September. But that means that the delivery of this vessel will be postponed by some 3 months. Inside the finished workboat, it will look like this, with the only exception that it will not be an engine there. There will be large batteries there, very large batteries there. In summary, everyday life will be better. Less noise, less pollution, no smoke and gas on board, very little maintenance as many elements are static. It'll be charged once a day with cheap power at night. You have agreement with the power station that will be cheap power at night with a plug and charging station, just like you do with electric cars. And the vessel will look exactly like this when it's finished, with a zero emission on the side of the vessel. So I say, thank you very much.
Thank you, Richard, for this interesting presentation into your very extensive experience in shipbuilding. We have some questions, and you have done very well on time. So let me start with one question. There was a question, I think it refers to the Brunvoll vessel. The question is, what is the total weight of the battery pack?
Ooh, I should know that. To be honest, I can't remember. I don't remember how the weight is. I could find out by just walking next door to my colleague here, if time allows, but I can't remember. I don't remember. It was huge battery packs, actually, two on both sides, actually. Mm-hmm. So it fills all the room there. So they have a lot of, they have so much weight that we had to increase the height of the vessel by 30 centimeters. Mm-hmm. Because it goes so much down. Yeah. So it's a significant weight, I could say. Yeah.
Yeah. Okay. And there's another question here. What is the operating cost compared to diesel? And this is a question that came in quite late. So it refers to your latest
we don't have the exact precise number, but we could say that it is it's much cheaper to have this one here.
Okay.
Much cheaper. It's the only answer I can give at this moment.
Okay, thank you. Another question here. Can you operate the boat on just a charge of the battery, or will you require charging during travel?
It's a good question. We charge it only once during the night, not during travel, but these boats, which we have designed here, they are for smaller trips, if you like. So they have, Bakkafrost, the salmon company, has carefully selected places where you actually sail for something like half an hour, and then you operate during all the day and come back again in the evening, and then you're recharging during the night. But it could, however, sail longer trips, and it could also do some tugging and stuff like that. But it's designed for the smaller trips.
Okay. Another question from Jóbjörn Skúlason. During the design phase, was there consideration to make the propeller larger than for a conventional diesel ship? Often it is stated that slower rotating, that is larger diameter propellers, are better fitted for electric engines. Was this a consideration?
Yeah, things were considered, and there were various options which were which were considered, but they came at a solution which, as they call it, were possible to just look at the note here, which were possible to. Sorry about this. Where it should be controllable pitch, as they said. That was the most important part of this, where you have to, the pitch is controllable, and then you have to, when you do that, you get energy optimization. The size of the propeller is very much like the size on the conventional catamarans.
Okay, thank you for that. Let's see, there are so many questions to choose from.
All right, good. Go on.
That's great. Let's see. Here's a question on the batteries. Are they lithium based? Do you know? Or liquid metal?
No, the first one. Lithium, yes.
Lithium based.
Yeah.
Okay. Let's see. Maybe we'll take one more and then keep the rest for the end of the session. Here's a question from Thorsteinn Másson at Blámi. He asks, do you see it as an option in the future to charge at the feed barge rather than only overnight?
There will be an option there. There could be. We discussed that as well, if one could do that by having some sort of facilities there. It would be possible, yes.
Okay.
And one would do that, perhaps do that on larger distances.
Yeah.
Yeah.
Okay.
Yes, indeed.
All right. So thank you so much, Richard. We will go on to our next speaker on the agenda. And this is Vegard Livik from Moen Marine. He is a project engineer, and Moen Marine is based in Norway, the largest shipyard in Norway, and is incidentally collaborating with our third speaker, Greenstat. So let's see how technology treats us now. See if you can share your screen.
And if I press this one and then this one. Do you know?
There we go. Yes.
Good, thank you. My name is Vegard Livik. I'm from Moen Marine, and I would like to present to you our solutions for low and zero emissions for our service vessels for the aquaculture industry and also fishing vessels. Moen Marine delivered its first battery hybrid vessel in 2019. It was a 20-meter fishing vessel called Angelsen Senior. Later that year, we delivered our second vessel, which you can see on the picture here, a 13-meter service vessel for the aquaculture industry. This vessel is what we call a zero hybrid solution, which means that we replace the diesel engines with electric motors on the gearbox and have a smaller generator to produce power while in transit. And when the battery is, and to use the batteries when you get to the fish farming location, to be running 100% electric. From its delivery in 2019, Edel, which you see on this picture, has reduced the fuel consumption with over 70% for Norwegian Royal Salmon, compared to a similar diesel mechanical vessel. Right now, Moen Marine has over 20 vessels under construction with this similar hybrid driveline, all vessels from 13 meters up to 26 meters. The only difference is, of course, the scale of the size of the motor, size of the generators, and size of the battery packs. When we first delivered the Edel in 2019, we saw this as a start of an evolution. The regulations was starting to coming to say that the aquaculture industry need to adapt by, I think it was 2025 and up to 2030. But what we are seeing is that the industry is changing much faster than we anticipated. So now it's more of a revolution. Moen Marine delivers and have delivered in average around 30 vessels per year, since 2014. And next year, we expect that 70% of all our deliveries and production will be with a battery hybrid driveline. We already see that the big, big players like Cermaq, like Lerøy, SalMar are already having a requirement of a zero or low emission alternative in all of their contracts for long-term service vessels. Operators that does not supply an option for a low emission solution will not be considered for the contract. So this has of course made all of the industry to jump on this to get to produce a vessel with a low emission or zero emission solution. When we designed our battery hybrid driveline, our focus was on efficiency and safety. You want to have as much as of kilowatt output from the one you put in, either if it's from the battery or it's from the diesel or it's from the fuel cell. That's why we all only use state-of-the-art equipment like Danfoss permanent magnetic motors and drives. We use a battery system from Akasol. I will come back to that later, which is all equipment that is renowned from other industries, that is well proven and are well proven in operating in a harsh environment like the maritime industry. Most of the big equipment are water cooled, which means they are compact and have a maintenance-free life cycle. This gives a very good, how should I say? This is very good for the maintenance cost, of course, of the system compared to a diesel mechanical system. In addition to the hybrid driveline, we also have developed an automation system that helps the user of the vessel to have as optimized energy consumption as possible. Whereas on a diesel mechanical boat, you have the motors running on idle, you have the PTO supplying hydraulic running all the day, even if the crane is not running. So on this Moania system, we have this, when the crane is not running, the hydraulic unit is not running. But as soon as you touch the handles on the controller, the hydraulic unit starts. So this helps the consumer to preserve energy throughout the day. Our battery system is produced by a German producer called Akasol. It comes in as this, like you see in this top picture, a stainless steel box, which has 15 submodules placed on a water-cooled surface, and it's IP67. So this gives us a very big flexibility in installing this on board the vessel. This same battery module is used by all of Volvo's buses, trucks, and in the heavy industry. The bottom pictures, you see a principle drawing of how we design our battery space. Having this battery design of the battery modules allows us to have a very compact battery space, which includes of course, all of the requirements from NMA and DNV, but it gives us a bigger safety because in case of a unwanted accident, like a thermal runaway, when you have a lot of gas and smoke coming out of the battery module, you have less space to ventilate out. So you get a very often ventilation of the battery space. So you avoid the gases and smokes to be filling up the room and basically being a ticking bomb. So you want that exhausted as quick as possible. And of course, these battery modules also has, well, we operate with the same terms of life cycle as they do at the Norwegian NORA, which is 10 years. But what we are seeing from our vessels delivered 2 years ago is that the energy drop per cycle is lower than expected. So we with some certainty now can say that the life expectancy until 70% of installed effect, it's at least 15 years. Before you need to change the battery system. But then again, when you change the battery system, the rest of your system will be ready for this kind of it will be ready for a battery system, let's say, and then you can install the state of the art. So we are now, this is generation 2 of the modules. On the first vessel, there was a generation 1, which was 24 kilowatt hour per module. Now we are on generation 2, which is 33 kilowatt hour per module, and we are already looking into aiding in development of the next generation 3, which will be 98 kilowatt hour per module. So you can see that the modules are getting bigger, the energy density is getting higher, but in the total cost of the kilowatt hour price is going down. So you get, instead of having like here you have on a normal installation, you have 10 modules, but instead of having 10, we can only, in 2 years' time, we only have maybe 3 or 4 modules. If you look at the data we are recording from Edel, which was the vessel we delivered to Norwegian Royal Salmon in 2019, and the operating profile throughout over a 2-day period, compared to a similar vessel operating in the same region for another company, Chimeric. These are designed identically. They have the only difference is, of course, the battery hybrid driveline. You see Chimeric is starting her motors early in the morning, running on idle, sailing out to the fish farming location on idle all day, some higher RPM during the day, and then idle again and back home. Whereas Edel starts a generator, runs it for 30 minutes. You can see the sailing route to the left from the land base, stops the generator, works 100% electric at the fish farming location all day, starts the generator and sails back home. And with this profile, she is using approximately 43 liters of diesel per day compared to Chimeric, which is using approximately 396 liters per day. So it's a big reduction in consumption, and there also a big reduction in emissions. This is an example of our smaller vessel, but earlier this week, we delivered a 15 times 10 meter service vessel to Scotland. So we have, I think it's in total 13. I think I was on a previous slide. I think it's 11 or 13 vessels, which is operating per now with a battery hybrid driveline. Airbox. This is a product we came up with after Aquanor earlier this year. Whereas a hybrid driveline is a no-brainer for new projects. You, of course, only here in Norway, you have between 2,000 and 3,000 vessels already operating with a diesel mechanical driveline. So then we developed Airbox, which is basically a power bank retrofit for already existing boats in the industry, where you can see this blue box, which includes the battery system, inverters, and power electrics to connect to all existing power distributions on the boat. And then you get the effects of supplying power for heats and lights, and also for hydraulic. So that means that when the fish farmer sails out to the location, he can stop the propulsion motors, and he can work 100% electric with this power bank using cranes and the capstans, etc. And then again, when he's sailing back to the barge or back to the land base, he of course has to start the diesel engine. But this is reducing. We expect it to reduce a lot of idle running hours on the diesel motor, which is reducing fuel consumption and also reducing at least maintenance costs. And this can be from 66 kilowatt hours up to desired effects based on how big hydraulic unit you need, how much hotel load you need in form of heat and lights. So this we can design specific for what type of boat it is and how big the boat is. And this also has a very flexible installation. It can be stand up like this, or we can put it flat out on top of the wheelhouse roof or wherever you have space. So you see, it doesn't require you to give up on your deck space for this battery installation. Since 2019, Moan Marine became a part of Scale Aquaculture. So instead of being only Moan Marine, we are now Moan Marine, a part of Scale. And being a part of Scale gives us the opportunity to also deliver a hybrid system for barges and other installations like mobile infrastructure. We also came up with a new product earlier this year, which is Econt, which is basically the big brother of Airbox. And this can be installed on barges to supply battery power to barges, or you can use it as a mobile infrastructure. Let's say you buy a hybrid vessel, but you don't have the charging infrastructure on your land base to handle the battery size, charging the battery overnight. Then you can buy the Econt, have it on land, and you can charge your boat from the Econt, and then Econt have 24 hours, let's say, of charging up before you need power again over to the boat. And this also opens for DC charging, which basically says that you can transfer a lot of energy on a shorter time from the, like here on the barge and to the boat. So let's say you have 30 minutes of break midday, then you can just plug it into the account and you can effectively charge up to 300 kilowatts during that half an hour. So it offers, and that again you will see when that you maybe not have to start the generator when you're sailing back home. So it also helps to reduce the running hours on the generator and make the vessel 100% electric all day. So you basically have a zero emission boat. But then again, have the flexibility of the diesel generator that if there are long hours or if you have to sail to another location, you have the flexibility of the diesel to do that sailing. And this is of course a container-based standalone unit which we just install where it's free space, either if it's on land or on the barge. And then you have the system, battery hybrid system, which Scale offers for all of its barges, which is built internally on the barge. And here you see an example of how this system works, where you have the 2 diesel gensets and a battery system. And basically this works that the battery system is supplying the barge during night or low, when you're not feeding, basically, when you have a low consumption on the barge, the battery system is supplying power. So you here also reduce the running hours on the diesel gensets. The benefits of this, which Scale is experiencing, is that they are reducing the fuel consumption on the barge by 20 to 45%. It's of course reduces emissions, and of course the maintenance cost. But also, like we see also on the hybrid vessels, that the fish is acting differently to a hybrid vessel operating in the fish farming location than a diesel. So. And I know that there are researchers looking into, do you get a higher feed percentage from the fish from the reduced noise? So, but this is not something we have. This how should I say, this extra cost or this extra saved cost is something we don't have in our calculations. Lastly, Moan Marine is. Now I have presented you our low emission, which also can be zero emission, but we are also working for the future and to see what is tomorrow's solutions for the service vessels. And there we are part of a Pilot E consortium, which the Pilot E is a funding program from the Norwegian Research Council, where we are designing and building a hydrogen-fueled service vessel. We are one part of the project where we are looking into the vessels, the sea side on the vessel, and you have the other side, which Thomas is going to talk later about, the land-based production plant of the hydrogen locally here in Rørvik, where I'm based. A part of that consortium is a local fish farmer called Salmonor, which have said that they are interested and are willing to buy this vessel and operate this vessel for us. The vessel itself and the system is very similar to the diesel battery hybrid. The biggest difference is that you take out the diesel engine, take out the fuel tank, and put in a fuel cell. And of course, you see there are some regulations and new land to be discovered here. But you have the pressurized hydrogen tanks here on top of the vessel. But hopefully we will soon be finished with the design phase and go over in building phase. So the vessel will most likely be delivered late next year. Yeah. Thank you for the opportunity to present to you our Moan Marine solutions. And if there are any questions, please feel free to ask.
Thank you, Vegard. I actually have a question on the vessel you just showed us on the last slide. You mentioned that the tanks you have pressurized hydrogen in the tanks up top. How have you envisioned, like, how are you swapping the tanks, or how is it fueled?
Right now, we are looking into the fueling process is one of the milestones that need to be designed, because fueling the hydrogen is a delicate operation, and it's something that requires, it takes more time than refueling diesel, let's just say. So right now we are looking into a solution where we're basically docking close to the production plant and refueling the hydrogen, but so we're not changing the tanks. We are refueling the tanks that are already installed, but all options are open to either change it or refuel it.
And this is obviously an important learning experience for the entire consortium involved.
Yeah, and also for the regulators, also for NMR and DNV as well. So we are basically pushing them ahead of us to challenging them in making a regulation that allows to open, how should I say, to make these kind of installations more available.
Absolutely. So we have some questions coming in. There's one question on the batteries. Are you aware whether the batteries are certified eco-friendly?
Yeah. We have also the same agreement that the supplier will start, the customer, the operator of the vessel have to pay the cost of the transport, but the supplier of the battery will pay for the recycle of the battery.
Okay, good. Also, here's another question. In your hybrid solutions, is there research going on for other alternative fuels, such as ammonia, methanol, or other? Are there any plans to have a pure battery electric solution, such as Mest introduced earlier? So 2 questions, really.
To answer the first question, we are looking also into biofuel, but we have concluded that the easiest way to get the flexibility of to compare the flexibility of a diesel battery hybrid is to have hydrogen battery hybrid. So we are primarily working now with developing this hydrogen boat, but of course all of the other options of zero emission fuels are something we are considering all the time. Also, for the last question, we have customers that has come to us and said we want a full electric boat, and we are projecting and seeing how much battery they need based on the operating profile, the sailing time, etc., etc. But often we come back to that, if it's better to have the flexibility of the diesel generator and then introduce like the air-count solutions to make eventually the vessel zero emission by operating purely on electric, because a lot of the barges here in Norway already have power from the shore, but the capacity of that shore connection power to the barge is not big enough to have an effective charging cycle at the barge. But if you have a battery there that can charge during 24 hours, and when the boat comes in, just to discharge that energy over on a short period of time, you eventually get a fully electric vessel. But of course, I think we were very close to start building a vessel with a lot of battery last year, but the customer stated that they wanted the battery hybrid, diesel hybrid solution because of this flexibility with the diesel, and also with they seeing that they are reducing the emissions so much anyway. So it's
So are you mainly serving the Norwegian market or European, global?
We are serving the global market. We have a lot of us. Earlier this month, a 24-meter vessel that we produced sailed by its own over to Canada on the west coast of Canada. Like I said earlier, we delivered our first battery hybrid vessel to Scotland earlier this week. We have vessels in Shetland, we have vessels in Iceland, we have vessels in Saudi Arabia, all over the world.
Are you aware that the driver for many of your customers is that looking to a zero emission solution to project a green image, or what is the main driver, do you think?
I think it's have a green image is a part of it, because I think that the market is looking, if you don't have a green image and if you don't have a documented reduced emissions over the last 5 years, I think that the buyer of the product is going to choose other options. And also you have these certificates like the ASC certifications and other global gap certifications that requires the fish farmer to document the usage of diesel and etc. I think there's a lot of things that is pushing the fish farmer to reduce its total consumption of diesel and CO2 emissions. But and the service vessels is a big part of this, of course, this production cycle.
Absolutely. So we'll take one more question, and then I will leave the rest for the end of the session. There's a question on the storage pressure of the hydrogen for the last this vessel that you're on the current slide. Yeah. And what is the amount of hydrogen stored on board in the tanks?
I think Thomas need to correct me if I'm wrong here, but I think the storage pressure is 300 bar, or is it 350 bar, somewhere around that, and the total amount of hydrogen is 100 kilos. 200. I'm sorry, I don't have that in front of my head, so I can't answer that correctly. But it's around 100 and 200 kilos of hydrogen, I think.
Okay. All right. Thank you. We are doing extremely well on time, so we will have, I think, ample amount of time for questions following our third presentation from Thomas Fiksdal from Grenstad in Norway. Let's see how we do on the sharing.
Okay, I'll try to share, Henriette, and thank you first of all for the invitation, and then secondly for the introduction here. Let us see if we are able to share. So can you see my presentation now?
Perfect, thank you.
Great. Okay, well, the title of my presentation is The Most Cost-Efficient Solution for Production and Bunkering of Green Hydrogen to Zero-Emission Aquaculture Service Vessels. Would first like to point out that we all target for zero emission, and in many cases, battery electric vessel will be sufficient to reach zero emission. But as both Richard and Vegard point out in their presentations, there are limitations by having solely battery electric vessels. So if you need a longer range or you need more power capacity for your vessel, then green hydrogen as a range extender could be a good solution. And that's what my presentation is about, how to produce green hydrogen and bunker the hydrogen towards the vessel. So in all cases, there will always be electric driveline in the vessel and a battery solution, but then there will be added hydrogen storage and a hydrogen fuel cell that produces electricity as well, so that you have a longer range for your vessel and also a higher power capacity. So let me see if I can get the next page here. Margaret, do you have an idea how I can get to the next slide?
You could try the up and down buttons on your keyboard.
I do.
Or clicking the slide.
Yes,
there
here
we
we
go.
Are. Great, thank you so much. So the company H2 Marina, we have a zero emission concept for the aquaculture industry, where we use electrolysis of water using renewable energy, that could be hydropower, solar, or wind, to produce to split water to produce hydrogen and oxygen. And where the main product is green hydrogen as a fuel for service vessels, but also as a fuel for power generators at the feeder barges. As an example, one diesel fuel service vessel would typically have an emission of 230,000 kilograms CO2 a year. And one diesel generator at the feeder barge would have typically 150,000 kilograms CO2 emission a year. So by replacing the diesel with green hydrogen, well, you will reach zero emission. Producing hydrogen from electrolyzers, we also produce oxygen, and the oxygen can be used in onshore small plants where there is a need of oxygen. In the electrolysis process, there is also a production of waste heat. And if we capture this waste heat and use it, it could be used for, amongst others, to heat buildings. So in our concept, we will take usage of the hydrogen as a fuel, the oxygen to the small plants, and also using the waste heat. So we use all the products, the main product and the byproducts. This increases the efficiency, of course, of the process, but also gives a better economy, which by the end of the day results in a cheaper fuel. So this drawing is made by my daughter. She draws better than me, so I think this is a good way of showing how the process is. Using hydropower or wind or solar, splitting the water into hydrogen, which can be used as a fuel, the oxygen, and the excess heat. And this concept gives fish farming companies the opportunity to reduce their emissions significantly without increasing costs. And I will come back to this regarding this item or subject, cost. It's very important for us to have a solution that is as cost efficient as the conventional solutions today. Richard very well pointed out in his presentation that hydrogen, until now at least, has been seen as more expensive than other solutions. If we will have success with our solutions, we have to take down the costs as much as possible. It's also very important for us that the customer shall experience the same flexibility and ease of operation as with compared to today's diesel-based solutions. No similar concept has been realized yet, so our solution will be the first one and a unique solution. And we offer, as earlier mentioned, to combine several needs, both fuel, oxygen, and heat. And we see ourselves as an energy company. So our revenues will come from the sale of hydrogen, oxygen, and waste heat. So why do we focus so much on aquaculture? Well, there is a need of consumption of all the products from the electrolyzers. We know there is a very high focus in the aquaculture business to target to become even greener than today. There is a strong economy within the aquaculture business. What we see in Norway, at least, the aquaculture companies are often family owned, which means there is a short decision gate, or at least shorter decision gate, to invest in innovative and new projects and solutions. And in Norway, we see that the aquaculture companies quite often has access to local renewable energy. At least the companies that are placed within the fjords very often also own the rights for hydropower production of electricity. So as electricity is the most important part of the electrolyzing project, having access to energy, renewable energy, will take down the costs of production of hydrogen. So, H2 Marine, we are lucky to be a part of two very interesting consortia. Vegard mentioned one of these. Those consortia here in Norway, they include the complete value chain from renewable power, hydrogen production, storage, bunkering, development of hydrogen fuel vessels, and also the end customer, the end user of the vessel and the buyer of the hydrogen as a fuel. So we are part in of one pilot E R&D funded project, and one called Green Platform, which is a similar project, but it's an upscaling project. In the first one, we develop a pilot solution. In the second, we develop an upscaled and commercial solution. In both these projects, the end customer is a part of the consortium, which of course increases the probability of realization of the project. In the pilot E project that Vegard mentioned, it's planned to commission and test the solution in Q1 and Q2 2023. And there is a great business potential for all the parties in the consortium, both national and international. And developing the solutions in these R&D projects, we open up for other and bigger vessels in the future, and also other, of course, end users. And our aim is to develop the onshore solution with lower CapEx and lower OpEx, which by the end of the day makes lower hydrogen costs. And this is important for us to have success. We really have to show that hydrogen can be a competitive fuel. So the value chain in the pilot E project is on our side to develop the solution for production, storage, and bunkering of green hydrogen. Whereas on the other side of the ship-shore interface, the hydrogen electric service vessel is developed by Moen Marine and Moen Shipyard in Norway. And the end user is the company SalmoNor, which is a big producer of salmon in Norway. So one thing is to produce or to develop this pilot project, but our business idea is to realize several hubs along the coast in Norway, and also hopefully international, where we serve 15 to 20 hydrogen fuel service vessels. By having a bigger amount of off-takers per hub, we reach the economy of scale, which then, of course, will take down furthermore the costs of the hydrogen. So this picture shows lots of offshore aquaculture locations in Norway. There are more than 1,300 fish farms along the coast. This arrow shows a specific location. And as you see, in a radius of not too far, there are several fish farms close to the location that we plan for here. And it will be within this radius convenient for 15 to 20 different vessels to come into our hub and bunker hydrogen as a fuel. And okay, so there are 1,300 fish farms in Norway, which equals approximately the same amount of service vessels. And if one hub should serve, let's say, 15 service vessels, well, then you can calculate that it should be the possibility of approximately 100 hubs. And our aim is to take, well, let's say 30% of the market, which then would say approximately 30 hubs producing local green hydrogen and offering bunkering of this fuel. So our solution is to have as few as possible components in the value chain. This gives us a lower capex investment cost, and of course then also lower operational costs. The solution should be mobile, and it should be an integrated storage and bunkering system, which then gives us a flexible solution. So the next slide shows on the top a conventional value chain for production, storage, and filling of heavy-duty vehicles, or it could be heavy-duty vessels. And on the lower part of the slide, you see our solution. You see less components. And the only difference here in our solution is that it will take slightly longer time to bunker. Vegard got the question, what is the storage pressure on board the vessel that they develop? It's 250 bar, Vegard, and we produce hydrogen at 350 bar, and then we transfer the hydrogen from the shore side to the vessel via with use of the pressure difference. And as you mentioned correctly, the storage capacity on board the vessel is planned to be 120 kilograms. So with our solution, we use the pressure difference to transfer 100 kilograms of hydrogen within 15 to 20 minutes, or exactly 17 minutes. Using a conventional solution, as you see on the top here, you will have some more components. You would have a high pressure compression, you would have a high pressure storage, and then to do the fast bunkering, which says, okay, 5 to 10 minutes, then you also would require the need of a cooling system. By using our solution, you take away some of the components and you have a less sophisticated solution. You need a little bit more time, but the ship is only planned to bunker every 5th day. So the end user says it's acceptable to spend 17 minutes every 5th day to bunker instead of 10 minutes every 5th day. So we are quite sure that this will be a solution that is more than acceptable for the end user. So now we are a little bit into the details there, but this is also, in my opinion, the fun part. These graphs, they show that it takes, as we see on the x-axis here, it takes 17 minutes until the power difference, the pressure difference between the shore side and the ship side is equalized. Then also the transfer of hydrogen stops. There is an amount of 100 kilograms hydrogen being transferred. And the important thing here is that the temperature of the storage tank on the ship has not become higher than 65 degrees Celsius. When you have this transfer of hydrogen, there will be an increase of temperature in the storage vessels on board. And that's also the limitation, the design limitation that we have to act upon. So being beneath 65 degrees Celsius, we are below the design temperature of the tanks, storage tanks on board. And we also see that we do not become lower on temperature on the storage tanks on the onshore side do not become lower than -10 degrees Celsius, and that's also within the design temperature window of the storage tanks. So this calculation or this simulation shows that our solution will work in the theory, and now it's getting very much exciting to see if it also works when we realize the project, but we are quite sure that it will. So, summary so far in our project. The theoretical calculations, they show that our solution will work satisfactory and that we will be able to bunker 100 kilograms of hydrogen within approximately 15 minutes. We will have operational costs lower, 5% lower than conventional solutions for hydrogen production and bunkering. The investment costs of our solution will be 20% lower than for conventional solutions. We have chosen the main suppliers. We have finished our detail engineering, also including HACCP, which we carried out last week. We are ready to take an investment solution in February 2022, which results in procurement, construction, and installation throughout the year. And we will then have commissioning and testing of our production plant in Q1 and Q2 in 2023. So this was my presentation. Thank you very much for your attention.
Thank you, Thomas. I think it's your presentation perfectly complements the other two that we've listened to previously. And again, we've done quite well on time. So we have lots of time for questions, and we have quite a number of questions. So I'm going to get started on questions for Thomas, and then we will get back to earlier questions that were posed to Richard and Vegard. So there's a question on the electrolyzer. How big is the electrolyzer you mentioned, Thomas?
Mm-hmm. Yes, this is a pilot project and it's a prototype. So this is a small electrolyzer. It's a PEM electrolyzer from the Norwegian company Nel. It enables to produce approximately 45 kilograms hydrogen a day. It's approximately 150 kilowatt electrolyzer.
Mm-hmm. So I actually have a follow-up question to that. When you talked about the hubs that will be located on the coast, do you envision that you will have an electrolyzer in each hub servicing, an X amount of vessels? And so how many electrolyzers in all? And that is how many hubs?
Yeah, that's a very good question. And the answer is yes, we will have one electrolyzer at each hub. The idea is to find the places where there is also in need of the byproducts from the electrolyzers, which means that we aim to place the electrolyzers at locations where there are also smolt plants that need the amount of oxygen that we produce as well.
Yep.
And we see that if we can have a electrolyzer that produces, let's say, 300 to 400 kilograms hydrogen a day, that's sufficient to support 15 to 20 vessels, and then the economy becomes quite good, actually, if we are able to sell the hydrogen as a fuel, the oxygen, and also in some cases the waste heat.
Good. Which actually brings me to the next question, which was specifically on the heat. So what is the quantity or the magnitude of the heat produced in the process?
One of the things with electrolyzers is that they have efficiency of approximately, let's say, 70%. So where do we lose the 30% of power input? And that's mainly in heat. It's a exotherm process, so you have a quite high amount of heat production in the process. So you can say if we are able to take out let's say 2/3 of the waste heat produced in the process, well, then if you put in 1 megawatt power, you can take out 0.2 megawatt as waste heat.
Mhm.
And by doing that, of course, you then increase the efficiency of the whole system.
Absolutely. Which actually is similar to another question that we have here. So you mentioned the efficiency of the process. So
Mhm.
what is the overall efficiency of this process compared to battery electric solutions or diesel? So you mentioned that there's a 30% or a 70% efficiency.
Yeah. Okay. So you have the 70% efficiency in of the electrolyzer. So you can say compared to using directly electricity and charging a battery solution, well, you lose quite a lot. And then the efficiency of the fuel cell that produces electricity from hydrogen, the efficiency is between 50 and 70% again. So you lose, it's no secret that you lose quite a lot of your power through the process, okay? From the electricity from the electrons to the propulsion. But it's still more efficient than I would say a diesel engine, which would maybe 40% efficiency. So when it's possible, you should of course go for solely battery electric vessels.
Mhm.
But when you need a larger range and you need more power, then at least in my opinion, the hydrogen and the fuel cell is the best solution, although you lose quite a lot of your input throughout the whole value chain.
Yeah. Which brings us really to money. It must make economic sense due to the price of electricity in Norway. So what is the price that you are working with?
For the hydrogen or for the
electricity?
Well, as you say, the electricity is at least, the cost of electricity is at least lower in Norway than in many other countries. If you have access to locally produced power, then the cost is as low as possible because you don't have to pay the cost for the grid. When we calculate the costs for our hydrogen, we say that we write a contract. It's called PPA, which means it's a power purchase agreement, which says 40 Norwegian øre per kilowatt hour. It's a little bit different for me to convert that into euros. I can try. I can do a small calculation on my right hand side here, and I will come back to you on Margaret. But for your Norwegian listeners, we aim for a cost of 40 øre per kilowatt hour for the power price or electricity price, and then we spend this electricity then to produce the hydrogen. So maybe the correct answer to your question is, what is the price for the hydrogen? And we have to come down to a cost of 6 to 7 euros per kilogram hydrogen to be compatible to MGO, marine diesel here in Norway.
And here there's also the important factor that you are indeed producing green hydrogen. So,
yeah,
because we're talking about the zero emission solutions.
You are right.
Yes. Right. Another question for you, Thomas. There's so many to choose from. There's a question here whether the vessels that you were talking about are 100% hydrogen or whether they are hybrid vessels.
Yeah, they are hybrid vessels. As Vegard pointed out, they will replace the diesel electric with the diesel electric hybrid to a hydrogen electric hybrid.
Mm-hmm.
So you replace the diesel engine with a hydrogen fuel cell.
So will the vessel be bunkering and charging at the same time, or how does that work?
Well, that will depend on what the rules and regulation by the end of the day will accept here in Norway.
Mm-hmm.
But I think that if we are able to bunker within 20 minutes, it should be possible to then charge afterwards.
Mm-hmm.
Batteries.
Yeah. Okay. So I'm going to go back to earlier questions that were asked previously, and let's see. Here's a question for Richard. Due to the weight of the batteries, was there consideration to use carbon fiber instead of steel or other material?
No, it was never considered,
Mm-hmm.
because we are in a harsh climate and we work under harsh conditions. So that was not considered at all. No.
Mm-hmm.
No.
Okay.
Another question, I don't know if I didn't answer that earlier. That was the weight of the batteries.
Mm-hmm.
And I looked into my notes here, and I can see that the weight on our vessel, which is 15 meters long, was 3.5 tons. Okay. times 2 on both
Mm-hmm.
sides. So it's very heavy.
Thank you for returning to that question. Here's another one from Vegard. Is the eCont connected to low voltage, or is it DC?
No, it's also connected to low voltage. So you have basically the DC charging will be happening, of course, from the DC bus from the batteries.
Mm-hmm.
But we also have this inverter converting the DC to the AC to power the barge or other equipment.
And I must imagine when I heard about this solution that it can be applied to a variety of applications. What type of applications is it used for so far?
So far, we are building the first one now. So we are hoping to have the first one in operation early next year. So, but it's like I said, it's either for the barge, or if you have a land base where the infrastructure is not sufficient, and
Mm-hmm.
Since it's mobile, you can basically lift it back on deck and take it with you when the vessel leaves for another area of operation. So
Mm-hmm.
it's kind of a flexible infrastructure, and also to have for a retrofit for barges that wants to cut the generator running hours.
Mm-hmm. And also, for the port itself, you don't necessarily want you don't want to spend the precious area that you have on the land side itself for this type of infrastructure. So I imagine it'll be useful for a lot of applications. So It'll be exciting to see how that plays out. Let's see, more questions. There is a question about, I guess this really applies to each of you. So some of these solutions that you have been talking about have been subsidized by national governments or the regional Nordic systems. Are any of the projects that you're talking about here, have they been on order without subsidies? So fully paid by the ship owner or operator?
If I may,
yeah.
Our projects have been funded by the Nordic countries.
Mm-hmm.
And if one should go ahead and be competitive compared to normal solutions, then the battery costs, if we go for the batteries, would have to go significantly lower than it is today.
Mm-hmm. Okay.
Yeah, most of our project also is funded by NORA. NORA basically says that for vessels under 15 meters, they subsidize 9,000 kroner per kilowatt hour of battery you're installing,
Mm-hmm.
up to a 50% of the total increase of investment costs. So I also think that without this funding, we wouldn't have seen as much interest in these kind of solution. But then again, on the other side, they are also proactive because they know that the CO2 tax is going up. They know that the regulations is coming. Maybe some areas they will be required to operate zero emission in the future, close to the future. And with the lifetime of these boats of 20 years, they have to invest for the future. And they also taking advantage of this fund that is available now, because when the regulators and NORA see that this kind of solution is normal praxis, they say that, okay, now job is done. Now since this is now the normal practice of the industry, we can focus them on other type of technology. So then this type of funding will go away.
Yeah, this is the pattern we've been seeing in the energy transition for other industries as well. It's so important to start now because depending on vehicle or vessel that you're talking about, they have different lifetimes, but this needs to be taken into considerations when we're looking towards carbon neutrality 2030, 2035, 2040. So we have a lot of work to do in the coming years. There's another question for Vegard here. Will the vessel be able to use the new MCS charging standard? This is, and there's a footnote to this, the new megawatt charging standard developed by Charin, I guess, the same organization that made CCS.
Yeah, we are right now for the DC-DC charging, we are using the CCS2 type of plug, but we are also a part of a process here in Norway to make a new standard for the maritime solutions. To see, we are looking into what type of plug is most convenient. That is, when you're going to transfer a lot of energy, you have to make sure that the safety first, to avoid the short circuits and etc. So I think now we are on the stage of having a first draft of this new standard, and on the new early next year we're going to have some demonstrations of what type of plugs we are going to use on a different type of power transfer, because now we are using a standard industry plug, 4-pin, 5-pin, 400 volt, 125 amps. But if you want to transfer higher amount of energy on the AC grid, you're going to need a different plug, basically, because what we are seeing also is over time a lot the heat and so we're working on implementing the solutions for high AC power transfer as well.
Good. I'll take one question here for Richard from MEST regarding the lifetime of the batteries.
Yes, in our calculation, we have said it's something like 15 years. And that's based on, that you use it properly in the operating profile, where you say that you never decharge it lower than 50%. So 15 years, something like that, we say.
Yeah. Okay, good. I think maybe as a closing question to each of you, maybe just as a brief answer as you can, since we have only a few minutes left. My question would be to you. Now, we've been talking a little bit about the support of governments and funding schemes and taxation and how important it is to promote and help the development of these zero emission solutions. So what could your government, or in fact the regional Nordic government bodies do to make your daily work easier? If we start with Richard.
If you ask about my government, I know they are working on some schemes where they try to subsidize some green initiatives, because they have targets as a nation where they say we have to live up to some sort of zero emission in the future. And they are at the moment developing some packages, and to our industry, they are saying that why don't we cooperate and identify areas where that could be feasible? And the maritime area is an interesting one, because that's one of the largest polluter, if you like. So that's one point. And the other one is the Nordic cooperation. That's been very useful so far, because we are a maritime nation, and so are many of the others. So we hope that that could be continue that cooperation. Thank you.
I agree. And Vegard, how about you?
Well, the Norwegian government is doing a lot already with the NORA and the pilot E projects and etc. But I think we need to have a little more, how should I say, consistency, that to make sure at least for the zero emission solutions with the hydrogen, etc. That the government can come in and help in the early stage when the first, let's say, 100-200 vessels are operating, to keep the production cost of the hydrogen low, to keep it compatible to the diesel cost. And also we need to stop subsidizing diesel prices to other segments like the fishing industry. The fishing industry gets a lot of subsidies for the usage of diesel. Yeah.
Good.
We have a plan to reach, I think it's a 50% reduction by 2030. But what we are seeing now in the industry is that actually the industry wants to go faster. So I think that the regulators also need to keep up and implement the regulations faster as well.
Yeah, absolutely. How about you, Thomas?
Yeah, I can agree to what Vegard says. And also, it's important that the authorities and the government in Norway are very clear that they really want to realize zero emission within the maritime industry. One example is that the Norwegian government has said that the longest car ferry route in Norway shall run on green hydrogen from 2025. It's in the north of Norway, from Bodø to Lofoten. And by doing this, well, then they start, then they are the end. Actually, it's the government that is responsible for these ferries, and they then set the requirement for the development of this zero emission technology. So I think that's also very important, that the authorities and the government set the requirement, and then you have the end customer. So you will have the development by yourself on a commercial basis.
So taking initiative and providing clarity for the future.
You're right.
Absolutely, yes. So I think that about wraps it up. We're actually over by a few minutes, but I think that's okay. We've had some really great questions that complemented the presentations that we've had here today. So I'd like to thank all of you for an informative session, great presentations. I think this really does leave me optimistic that the energy transition is indeed in full swing, and it definitely makes sense to tackle low-hanging fruits such as these smaller vessels and, for example, passenger ferries and other vessels that are moving short distances. We've seen different solutions discussed here today: hydrogen as a range extender, hybrid systems to reduce emissions, going towards zero emission, an important circular concept using all the materials that are used and produced during the cycle. And again, no surprise, it's clear that funding and incentives are needed to push and mobilize development. And indeed, the phase out or the stoppage of subsidies for fossil fuel are also equally important. So I'd like to thank our speakers, 3 here today, for participating, and also a great thank you to our attendees today. And surprisingly, we've had no earthquakes here in Iceland today, so that's always that's always good. And I must mention, technology has been on our side, so that's a very happy end to today's session. So I thank you again, and wish you a pleasant day and week.
Thank you.
Thank you very much.
Bye.
Thank you.
Bye-bye. Bye.
Bye now.